Hello everyone, my name is Nigusse, PhD student at Ghent University. Today I'm going to present my paper entitled with Evaluation of Silver Coated Textile Electrodes for ECG Monitoring. Introduction. ECG is the process of recording the electrical activity of the heart. Long-term ECG measurement is very important for early detection and treatment of heart-related diseases. Traditionally, silver chloride electrodes are widely used for ECG monitoring. However, such electrodes are not suitable for long-term monitoring due to some limitations, like they need intensive skin preparation, they cause skin irritation, and they suffer from drying during long-term use, and they are disposable and they are costly. So because of this, textile electrodes could have an important role to replace such gelid electrodes. Here are some examples of textile electrodes, but still there are some challenges related to textile electrodes. One is the absence of permanent and stable skin contact, which leads collected signals to be contaminated with noise and motion artifacts and have high and variable contact impedance and generally poor signal quality and wrong clinical diagnosis, which led to wrong clinical diagnosis. So due to this, such textile electrodes are not yet in routine clinical use. In this research, we developed two types of electrodes, embroidered electrodes and printed electrodes. The embroidered electrodes developed by using the silver-plated polyamide yarn and embroidered on cotton fabric using computerized embroidery machine, and the silver printed electrodes developed by screen printing of silver ink on knitted cotton fabric. ECG measurement was carried out with lead 1 configuration system, where the electrodes were wrapped on place using elastic strap, and ECG measurement was carried out at sitting and walking conditions before and after washing of the electrodes to evaluate their washability, and the collected signals evaluated based on visibility and amplitude of the major peaks and RR interval and heart rate. When we come to the results, the developed embroidered electrodes have 0.8 ohm per square surface resistance, and the silver printed electrodes 1.64 ohm per square surface resistance, which is acceptable conductivity to use as electrodes. The collected signals have clearly visible major peaks, as we can see from the diagram, and this shows the developed electrodes are capable to capture acceptable signal quality, which is comparable to the signals collected using standard ones. When we compare based on the RR peak amplitude, signals collected using the embroidered electrodes have higher signal RR peak amplitude, that is 1.28 millivolt compared to the others, and the RR interval signals collected using the silver printed electrodes show higher RR interval and higher standard deviation, which shows such signals have lower signal quality compared to the signals collected using embroidered electrode and standard ones. We also studied the effect of body motion on ECG signal. During dynamic situation, there is a difficulty of keeping the electrodes attached on the contact place, and this results to lower signal quality. From the collected signals, we can see the signals, they are contaminated with noise, but still major peaks are clearly visible, and they are capable to determine the heart rate. We also studied washing effect on ECG. After one wash, there is no any deterioration in signal in both the embroidered electrodes and printed electrodes, and all signal error major peaks are clearly visible, which are comparable to signals collected before washing. Here are some of the references used. Thank you very much. This is all.